Hello friends, how are you? In the last class, we have discussed about the superposition of waves. Superposition is the additive effect of two or more than two waves, and this generates a new displacement. It depends upon the phase of the waves associated with it. The superposition of two waves traveling in opposite directions lead to a concept of stationary waves, water stationary waves. Okay, so the most important features of a stationary wave is that boundary conditions of the system boundary conditions of the system restricts their possible wavelengths or possible frequencies. It depends upon the boundary conditions or limitations of the system. Example, oscillations or vibrations in a string or open pipe, like that. So the interference of two different waves moving in different direction lead to a new wave called superposed wave, and that is in different stages of time they form different waveforms. Sometimes we get waveform of higher amplitudes, and sometimes we get zero wave, or that means at when amplitude is equal to 0, we will get no waves or zero wave. Okay, in the similar way, what happens after some time interval, again we will get maximum amplitude, or the value of amplitude varies from 0 to a or 0 to maximum at different instances of time. It depends upon the value of time. Therefore, the system oscillates with characterized set of frequencies called natural frequencies. As the boundary conditions of the system, that is a length of the string or open pipe, we have definite values of frequencies which are called natural frequencies or normal modes of oscillations. So the possible wavelengths of stationary waves are expressed in terms of length of the pipe or length of the string, and the corresponding values can be obtained from the expression of wavelength of the stationary waves. Hence, depending upon the values of n here in formulas, then we have different modes in different modes or different harmonics. The lowest natural frequency, lowest possible natural frequency, or is called first harmonic or fundamental mode. The lowest possible natural frequencies are called fundamental or first harmonic. And similarly, when terms increases, that means for second harmonic, third harmonic, and so on, we can obtain from the mathematical relation. Sitar and violin are the good example of these principles. Okay. Similarly, if we consider an air column closed at one end and open at free end, then amplitude is 0 at the closed end and maximum at the free end due to the pressure difference. So we get wavelength equal to the odd multiples of length of the pipe, and corresponding normal modes or normal frequencies are obtained, and higher frequencies are odd harmonics, that is odd multiples of the fundamental frequencies. So sometimes it is necessary to carry an oscillation in many cases. Then an external source is used to overcome the dissipation of energy to, uh, to keep oscillation continuous. That source is called an oscillator. If the frequency of the external source or oscillator is close to the natural frequency of the system, that means the frequency at which stationary waves are moving. So these natural frequencies, then the system then the system oscillates with a higher amplitude value or large amplitude value. This condition is called resonance. Okay, that means when the external source frequency match with natural frequency of the string or natural frequency of vibrating air column, then we can say it is a phenomenon of resonance. Resonance is what the in that case uh, amplitude of the wave is maximum or large, and this shows the condition of resonance. So example of resonance is that the breaking of a building during earthquake, because earthquake is what it is, a vibration of earth surface or plates of earth. So if the frequency of earthquake is matches with the frequency of oscillation of building, then amplitude of the oscillation increases. This may cause breaking of building. And also soldiers are asked to break rhythm while crossing through a bridge to avoid resonance. One more interesting phenomenon we experience in our day-to-day life, that is the interference of the two waves of slightly different frequencies but of same amplitude. In that case, what happens? The resultant wave of the two sound waves or sound waves, they overlap or they superpose to form a packet of waves. That why I am saying packet of waves, that means sometimes we will get some amplitudes, and at some time we have zero amplitudes. So that within the time interval, what happens? We have sometimes some amplitude of the two waves, summative effect of the amplitude of the two waves, that is one packet, and after that packet we experience zero amplitude, and after that time we again for some time interval get some amplitude value. So each time this packet moves with respect to time. So we are called that form is called waxing and waning of waves. Okay, waxing and waning of sound waves. The phenomena of alternate waxing and waning of waves is called beat. We experience beat while listening songs in a concert, or playing a musical instrument of different types, and sometimes in orchestra. So the phenomenon of beat is useful in determining unknown frequency of a tuning fork for tuning musical instrument, in electronic communication, and in mines. Hence, amplitude of a beat is variable with respect to time, and we can find beat frequency by the difference of two frequencies of the